All right, number 37. Jeremy deposited X dollar in his investment account on January 1st, 2001. The amount of money in the account doubled each year until Jeremy has $480 in his investment account on January 1st, 2005. What is the value of X? Okay, so pretty much the amount doubled each year. So we're starting with X dollars and it doubled each year. And then at 2005, the total is $480. Okay, so that's how many years? And so if you go from January 1st, 2001 to January 1st, 2005, that's how many years here? Yeah, we can subtract the two number, right? So that should be 4 years, 2005 minus 2001, right? I think that should be 4 years. So pretty much in 4 years, the amount went from X dollar to $480. We're trying to figure out what X is. Okay. What we could do is we could make a little table. Okay. We could make a little table. So see, and then we can just, since it's not that many years, we could just go step by step and then try to go backwards and figure out what we begin with. All right, let's just say this. First column, we can make the year. Okay, and then this is the total, second column represents how much money he had. All right, so we know in 2001, January 1st, 2001, he started with X dollars. Right, and then in 2002, 2003, 2004, 2005, right? So then at year 2005, we get how much money? 480. Right, so you see, to figure out X, we had to go back. Right, we know each year it doubles, so if we go backward, we had to divide it by 2. Right, so I had to go back 4 times pretty much. Okay, so be 480 divided by 2. So in 2004, it should be $240. Okay, and the 2003, we divide by 2, will be $120. Go back one more time, divide by 2, we get $60. And then lastly, go back one more time, X should be 60 divided by 2 is 30. All right, so we know X should be 30 then. He started with $30 in the year 2001. All right, and that will be the answer. So that's one way to do it. Okay, we can make a little table. And for this question is a good way to do it because we don't have that many years. So we could just kind of go back, right, a couple of steps. Right. But we could have some question where, what if we're asking how much money he will have in 20 years, right? Or 30 years. Right. So if we do it like a table, then it'll take a while. Okay. So I just want to show you this. For this question, we can also write an equation here to model this. Okay, so since the amount doubles each year, and so that means from 1 year to the next, we're multiplying by 2. So since here we have a common ratio that we multiply, then this will be an exponential growth. Okay, so this is an exponential growth model. Okay. Now for exponential growth model, what we can do is we can say the equation will be y equal to a times r to the x power. Okay, a times r to the x power. So and then to relate to a model here, right? The y value will be how much money we have, and here the x value will be number of years, so that will be t. Right. So let's just change it to a t to represent time. Okay, so in the exponential growth model, what happens is the a value is going to be the initial amount. Okay, so that's a number that we begin with. All right, so a value is what we begin with. Right, and then the r value is the growth ratio. So that's the number that we multiply from 1 year to the next. Okay, and we already said the r value in this case, since it doubles, right, r will be 2. So to the equation will be y equal to a, we don't know what we begin with, right? That's what we're trying to solve. So in this case, that's x. and then R's ratio is 2, and then T is how many years? We said it's 4 years, right? So we can solve from here. And we know the total amount that he had after 4 is 480. Okay, so this will be our equation. So to solve it, will be 480 equal to x times 2 to the 4th. 2 to the 4th is 2 times 2 times 2 times 2. That's actually 16. And then so to solve for x, we can divide by 16 on both sides. Okay, so once again, we get x equal to 30. Okay, so that's another approach to solve this question.